Good night to everyone. Welcome back to CDP Labs Edu Services. I am here. I am Ronique Bernard, your host and your teacher for this evening. I'm just waiting for our, what do you call it now, virtual Inside Studio students, right? Just waiting for them to join us. I sincerely hope that last week, Thursday's class was a good one for you. And today promises to be another good lesson. And of course, I'll be taking it through a part of the syllabus, maybe a part that you have not yet touched or completed, that heredity and variation. So if you have not yet done heredity and variation, then tonight is a night for you. And of course, we'll be continuing to look at our January 2021 past paper. But first, we'll go through heredity and variation. So just stay tuned as we wait for our host. If you're here with our host students, if you're here on our YouTube channel, I ask that you say something in the chat that I can recognize you. All right. And welcome you to CDP Labs Edu Services. I ask that you be kind and generous to others by sharing the link with your friends who you know will be doing exams next week. And if there's any family member who you know will be doing exams next week, so I just ask that you share the link with them. Oh, good night again to you, Jennifer. I hope tonight will be another blessed night for you. I hope last week was indeed a blessed one for you as well. So, good night, Jennifer. Nice having you back again as I wait for the students who are supposed to join this class. And we have our first one here. Gabriel is here. Let me let in Gabriel. All right. Good night, Gabriel. Gabriel, good night. How are you today, ma'am? How are you? You not hearing me, Gabriel? Oh, your mic is still. Okay, wonderful. All right, so we're gonna. I think Eileen is supposed to be joining us as well, so going to give her some time to join. Let me. Give me a second there. All right. Okay, I understand that. All right, just waiting on Eileen to join us. All right, so just want to say welcome again to those persons on YouTube, and of course to you, Gabriel, as we are about to start our Human and Social Biology Marathon Part 2 tonight. Good night. Is that Chelian Chang? Could you tell us where you're from, please? Which country are you from? Are you from Jamaica or are you from another Caribbean island? Where in the world are you from? Could you tell us where in the world you are from, please? You're from Guyana. Okay. Lovely. Lovely, 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 lovely. Well, it's pleased to meet you. And I'm, of course, Ronique Bernard. Of course, I am Ronique Bernard. And of course, I'm a Jamaican. And I've been a teacher for the last 17 years. Yes, 17 years I have been teaching. And I've been teaching for CDP Labs Edu Services since 2009. So you can do the maths and you'll know how long I've been teaching with CDP Labs Edu Services. All right. So we're going to wait until I'm going to wait until another student joins us. I'm not sure she's ready as yet, but we're going to start our lesson tonight, of course, with devotion as usual. And just going to share a passage of scripture with you before I pray. And I must, you know, oh, Jennifer, you're from Guyana too. Okay, wonderful, wonderful. So, Jennifer, tell me something. Were you the one who invited Shelly? Jennifer, were you the one who invited her? Well, Shelly, let me ask a question. You said that um, you have been missing the streams. Let me ask you a question. Did you subscribe? Did you subscribe like Jennifer did? If you did not subscribe, then that's why you're not catching the streams. All right. Oh, you don't know each other? Okay. Let me introduce Jennifer. Jennifer to Shelly. Shelly, Jennifer to Shelly. Well, like both you guys can take your. I don't know how you're going to communicate with each other though, but you can find some way of communicating with each other. All right. So, God, hope God will bless you this evening as we go through another night of human and social biology. And I sincerely hope that um, you are ready to take notes, not just take notes, but to use whatever is necessary. Because my type of class is student centered, and I'll be guiding you through what you need to do in becoming prepared for your exams. Oh, you said, of course, you subscribe, but you just got. Oh, well, to be notified, you have to click on the bell. So if you didn't click on the bell, then maybe that's why you weren't notified. So I guess this time you click on the bell, right? We'll be coming on live again Monday night, and of course, for a short time on Tuesday night. We'll be streaming early Tuesday, um, very early, because you need to get some rest so you can respond to those questions. All right, without any further ado, I am going to share a passage of scripture with you. And today, our devotional text is coming from the book of Proverbs, chapter 10. Um, I sincerely hope that you'll be blessed by hearing a word from, you know, God, of course. Proverbs chapter 10, you'll be reading from verses 2 to 4. It says, ill gotten treasures have no lasting value. You know, ill gotten treasures have no lasting value. Meaning that if you if you get something without working hard for it, some persons do wrong things to get their treasures. And God is saying to us that these things that we get by doing wrong things have no lasting value. But righteousness delivers from death. Verse 3 says, the Lord does not let the righteous go hungry, but he thwarts the craving of the wicked. So, if you're on the Lord's side, I tell you that God says he will not let you go hungry. And our final verse for tonight says, this I want to come right home as you prepare for exams. As you prepare for your exams, it says, lazy hands make for poverty, but diligent hands bring wealth. It says, lazy hands make for poverty, but diligent hands bring wealth. What is that saying? How can we apply that proverb to our studies tonight and throughout the rest of your life? Now, if you are lazy, then you may not get up out of your slumber, out of your bed, and start studying for exams. And guess what? Lazy hands make not just poverty, but failure. But diligent hands bring just not wealth, but success. So remember Proverbs 10, verse 4, that lazy hands make poverty, but diligent hands bring wealth. Good night, Elaine. Okay, good night. And Elaine said good night to everyone else. But good, Elaine, it's just you and I who was in Zoom tonight. And we have our guest students from Guyana, Jennifer and Shellyan. Good night to you as well. So I pass on your good night to them. And I believe that they have heard so. Now, usually I would have played a song, but tonight I think I'm going to try something. Um, I'm going to just sing one verse of one of my favorite songs. One of my favorite songs. Just one verse and the chorus. The book of Proverbs is filled with a lot of wisdom. And when you trust God and obey God, He will come through for you. So, I will try and sing tonight. I will try and sing tonight. One of my just one verse on the chorus, and then we'll pray. When we walk with the Lord in the light of His word, what a glory He sheds on our way. While we do His good will, He abides with us still, and with all who will trust and obey. Trust and obey, for there is no other way to be happy in Jesus but to trust and obey. Most kind and loving and heavenly Father, we give you thanks, O God, for sparing our lives to live to see the end of another day and the beginning of a new day. And Father, as we're about to continue our preparations for exams, we ask, dear Lord, that you will forgive us now for our sins, that we may have trespassed against you knowingly or unknowingly. Dear Lord, I put before you these students who are here on YouTube, on Zoom, and those who will be watching even later on, and those students across the Caribbean who will be preparing for their human and social biology exam. I pray, O Lord, that you will continue to be with them as they study their Father. Pray that you will direct them to the information that they will need to be successful in this exam. And may, as they are successful, they will recognize that because they have trusted and obeyed you, you have brought success to them. So glorify your name now in their lives. For this I ask, in Jesus' most precious and holy name we pray. Amen. All right. Okay. Thank you, Miss Chang. Thank you. And to God be the glory. All right, so we're going to go straight through to our syllabus. And remember, our class is a very interactive class. I like when my students respond to my questions. I don't like when students just watch only, because this is not a theater. This is a school. This is a class where teaching and learning should take place and will take place. So here we go now. We are looking at, good night again, Elaine. Just testing me. I hear your voice, Elaine. Elaine, are you hearing me?
I'm here, sir. I'm here.
Okay, lovely, 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 lovely. All right. So we're looking at heredity and variation, section C of the syllabus. Um, the objective clearly states that the student should be able to describe the process of mitosis. Good. Now, when the exam asks about describing, and from time to time, I would have shown my students that when CXE asks you to describe, they are not only expecting, it's not a must that you only use words only, but they suggest to you that you can use both diagrams and words together, or drawings and words together, an appropriate combination of both words, drawings, or diagrams and drawings. So when you see the word describe, don't get too trying to memorize everything. Practice now. A matter of fact, practice to describe using diagrams and drawings. And we'll be looking at a few examples of such delight. Now, you're expected to give the definition of mitosis, right? So we're going to be looking at the definition of mitosis, movement of chromosomes during mitosis. Now, note that it says that the names of stages are not required. But look at that. Diagrams are required in their description. So you have to practice. You have to practice. And I'm going to give you a little technique that you can use, or an idea that you can utilize to make it much easier for you to learn. Now, objective number 2 clearly states that we should explain the importance of mitosis. Why is this important? Why did God, in his all his wisdom, institute this thing in our body? Why mitosis is very important. Good night, Freeze. Good night. That's Zara Freeze. All right. Pardon me for the spelling of the name, but Freeze, good night. How are you? Which country are you from? Where are you from? Which are you from? Guyana as well? Because we have two Guyanese, two lovely persons from Guyanese. Which country are you from? All right. So when we talk about stating the importance of mitosis, you're saying, why is it important? Note in the explanatory notes, it says production of identical daughter cells. So if you have daughter cells, it meant that you had a parent cell. Good. So you have to start from the parent cell. Oh, Grenada. Good night. Good night from Grenada. Good night. Good night. Thank you for joining us on CDP Labs Video Services. Hope tonight will be a blessed night for you. So, when we talk about production of identical daughter cells, having the same number diploid and type of chromosomes as the parent cell. Note, so the same number that the parent cell had, the daughter cells will also have. Say sometime in the multiple choice, they will ask such a question: how many chromosomes? Good. Now, so we'll be looking at that as well. So please note that in mitosis, the daughter cells has the same number of chromosomes, and type rather of chromosomes, that the parent cell has. Good. Now, in the notes here, it is saying to us that the mitosis is important for growth, repair, and asexual reproduction. Three things: for growth, repair, and asexual reproduction. So it is a very good idea to read your syllabus because the syllabus give you the short notes. Good. All right. Now, objective number 3 says that we should describe the process also of meiosis. And the definition of meiosis is important. Movement and separation of homologous chromosomes. Now, homologous chromosomes and the subsequent separation of chromatids. So please note the vocabulary here: homologous chromosomes, chromatids. Please note the vocabulary. As you want, when you go into the exam and you look at the exam paper, that you're in fact seeing these words, and it should not be strange to you because you have studied it, you have read about it, you got some understanding about it. So next time you see these words, you should know them. So you have an assignment. Look up the definition. Guess what? My students from YouTube, you will have a task as well because you're going to have to do some research and put those responses in the chat. Are you ready for that? If you're ready for that, say, I am ready to do research and participate as an active student. If you are ready, say ready. All right. Now, objective number 4 says, explain the importance of meiosis. Again, so two things. So these two processes, right? Mitosis, meiosis. You are required to describe both of them and also give the importance of both of them. So it says the importance of having the chromosome number, which is applied. All right. So Jennifer says, ready. Oh, so, okay, very good. So you're all ready. Very good, very good. Wonderful, wonderful. So when the time comes, make sure you do your job. All right. And Elaine, are you ready to do your research? Elaine? Elaine? Elaine gone left me?
I'm here, sir. I just move from my spot because I cannot hear well.
You're not hearing well?
I'm hearing no because I moved from where I was.
Oh, you're looking for a spot. All right, no problem. So it says importance of having the chromosome number applied. So there's a difference between the diploid and the aploid. So aploid mean half, diploid mean 2. Now, your first research, get ready now, your first research, what is the number of chromosomes in the nucleus of the cells? What is the number of chromosomes in the nucleus of a cell? Look it up. The number of chromosomes in the nucleus of a cell. Do your research quickly. The number of chromosomes in the nucleus of a cell. Who's going to give the first answer? The number of chromosomes of the nucleus in the cell. Let's choose first on our YouTube channel, and of course, Elaine, let's see if you beat them. Number of chromosomes in the cells. So I'm waiting. All right. Well, okay. All right. So we got two answers. All right. We got two answers. So Shelley says 46 chromosomes, and Jennifer says 46 chromosomes. Very good. Freeze, what do you say? Do you agree with them, Freeze? You did your research, Elaine?
It's 46, sir.
Yes, just 46 indeed.
46. I'm putting 3 pairs.
Okay, very good. So, so the applied number of cells, sorry, the diploid number of cells is 46 chromosomes, but the applied is 23 chromosomes. Okay, I agree with them, please. Very good. So you have done your first assignment. Well done. So, because I want to tell you why I ask my students to do things is because one, the Chinese proverb says, "What I do, I understand. What I see, I remember, but what I hear, I forget." So when you participate in the class, you will certainly learn for yourselves. Wonderful. So, so you're all correct. So the diploid number of chromosomes that the parent cells has is 46 chromosomes. And in the meiosis now, the daughter cells will have 23 chromosomes each. All right. So the importance of having the chromosome number in the formation of gametes, importance of meiosis in introducing variation into gametes. So now we understand where variation comes from. Variation takes place during the process of meiosis. Variation. What do we mean by this big word variation? You know, you look like your mommy, but there's some difference. You look like your daddy, but there's some difference, right? Of course. Okay. And we're going to look at something special, right? Now, explain why genetic variation is important to living organisms. Now, examples of variation will be height, weight, gender, blood type, tongue rolling. You know,
Yeah.
yeah, go ahead. You were
I
saying
was saying
something?
color too. I was saying and color.
On
The
color.
color.
Okay, on color. All right, color. All right, good. And number six says distinguish between generic variation and environmental variation. No, sorry, genetic variation rather, and environmental variation. Now, so we want to include the difference between continuous and discontinuous variation, and we'll be looking at that later down. Now, genetic variation has to do with obviously meiosis, and environmental variation has to do with your surroundings. All right, all right. So that is just six out of 11 objectives, and we'll come back to the other five shortly. All right, so let's go to tonight's presentation. All right, can someone identify these two persons for me, please? Can anyone identify these two persons?
Venus and Serena Williams.
Okay, Elaine says it's Venus and Serena Williams. Note the word Williams. What about Jennifer and Shelley and Freeze? Can you identify these persons? Is Elaine correct? All right, wait until they get to the answer. All right, now when you look at the picture? Oh, Shelley, you don't know? Well, the taller one is Venus, and the shorter one, I gave away something there. I shouldn't have given away anything. Oh, you was gonna say Serena and Venus. Yeah, you're correct though. It's Serena and Venus. Venus and Serena, the Williams sisters. All right, I kind of gave away something. I shouldn't have given away. What I kind of give away something? Question though. Do, they're identical twins. Good. Very good. Hmm. Very good. Very good. Wonderful. Good. But what's the difference between these two twins though? What's the difference between these two sisters? What's the difference between these two sisters? You can answer. So. Oh, they look different. Okay, all right. Okay, freeze. Okay, all right. Elaine, what's the difference between these two sisters?
Um, one is more darker in color and
Mm-hmm.
lighter.
Mm-hmm.
So, but so far.
Okay, all right, good. All right, so I'm seeing where Shelly is saying their teeth, their height, their body weight. Okay, all right. Okay, very good, very good, very good. And their height, and Elaine said their color. All right. Now, if you have seen their father, if any one of you know their father, which of the two sisters takes the height of the father? Have you ever seen the father, Elaine?
Sir?
Yeah?
No, sir.
Never see the father
No,
yet? Never see the father? Okay. Well,
no.
all right. The
I
father. Yeah, go
them
ahead.
no, sir.
Yeah, go ahead, Elaine.
I'm saying I don't really follow them up, so I wouldn't know.
Oh, you don't follow them up. All right, no problem with that. All right. The father is tall. The father is definitely tall. So it is evidently that if they take it, if both of them get a gene from their parents, then it simply meant then um that Serena took the common T. When we get to variation, we'll get to the whole miss and match the s- the when you're actually doing the genetic boards when you're matching, all right, with whether when you have dominant and the dominant gene, etc. We'll be getting to that as well. All right. Now, so I want you to focus now on these two sisters as we get into our lesson. They're going to be our instructional materials, right? So focus on these two sisters. All right. So let us get into the first part of our lesson. Now, of course, you are required to know the definition of mitosis. And it says mitosis is a type of cell division. Now, when I'm in, I like to encourage my students that when you're reading, you can draw what you are reading. Draw what you are reading. So I'm going to draw a cell, a circle to represent a cell. So this is a type of cell. Now, this cell is going to divide according to the definition. You see? So when you draw what you're reading, it forces you to interpret it. And once you're interpreting something, you're going to naturally understand it. So don't just read like that to recall it. No, 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 no. Read to understand. So there's a technique that we call visual literacy, where you try to turn words into pictures, and you also turn pictures into words. So if you're looking at the pictures, what I advise you to do is to not just look at the pictures, but write sentences or paragraphs describing what you are looking at. Oh, yes. And I might give you a chance to do that as well. I'm going to give you a chance to do that. Why not? Good. So let's continue. So a type of cell. So this represents the type of cell, and we see the cell division taking place, which involves the division of the nucleus to produce two uh, daughter cells. So this is the essence of it. Two daughter cells. Eh? Good. Am I making sense? Am I making sense?
Yes, sir.
Okay. So the type of cell which involves the division of the nucleus to produce two daughter cells. Same number, same kind of chromosomes as different cells. So you could say, okay, 46, chromosomes, and the daughter cells have the same 46 chromosomes. Good. And of course, you can label it and say this is the, you can label it and say this is uh, parent cell. You do things that in the exam, make life much easier for you. So you label that, that's parent cell. And of course, you're going to label these two as what? Daughter cells. And you could also label right here the division of what? Nucleus. So what I just did was to just do a little drawing representing what I read. And now I'm just putting the words. That is what CXC talking about. A combination of words and drawings. Good? Division, I could say nucleus dividing. Put it in my own words. What do you say? Nucleus dividing. Good? So, parent cell, the nucleus of a parent cell, divides to give us daughter cells. See? Simple. Make sense? So I basically drew a diagram based on the definition that I read. Tell me in the YouTube chat if that makes sense to you, please. Just let me know if that makes sense to you, please. All right. Remember to share the link with a friend. Share it on your Facebook page. Share this channel on your Facebook page. Encourage your friends to come on. All right. So if what I just did make sense to you in YouTube, just let me know if it made sense to you. All right. Now it says mitosis occurs in a somatic cells, which are all body cells. So of course, I could label this as a body cell. These are body cells, right? So it occurs in a somatic cells, which are all body cells. Uh, yes, that's true. Okay. Oh, good night, Ruben. How you doing? Welcome back, Ruben. Welcome back. Um, Gabriel was having connectivity issues, and I'm not sure if Tangini has access to the internet because she did not read the message. Yeah, Tangini apparently doesn't have access to the internet, so that's why it is you and I. But you feel lonely, Aunt Elaine?
Kind of, sir.
Well, we have company on YouTube. We have company on YouTube. Don't worry yourself. We have company on YouTube. All right. Okay. What you could probably do is you could invite. I had invited Vivette before. I mean Thursday night, but you could invite her. Let me find out. I could send her the invite now if you wish.
Yeah, 'cause I think she's right now. Yeah, I think so.
So she should be free now. Okay. Let's hope she's free now. Vivette. Well, okay, I sent the link to her, so we have to join. All right. So, okay, Jennifer, thank you very much. And yes, good night again to Ruben. I do appreciate my Caribbean neighbors joining us tonight again. It's been great with you last week and the week before. All right. So, just it's a good idea that when you're reading something, you don't just read like that. But if you really want to understand what you're reading, it makes a lot of sense that you draw something. You don't have to be this great artist. I just draw some shapes, just to depict what I'm reading. Good. Now, mitosis helps to replace dead cells and for growth and the development of organisms. So the third the third point here is telling us the importance of mitosis. It is telling us the importance of mitosis. So make note of this. Is to replace dead cells. And you can be creative and draw something and say dead cells replaced by new cells. Good. New daughter cells, right? And for growth, you could draw something growing and say this is for growth and the development of organisms. So here you have it, the definition of mitosis and why it is important. Simple. All right. So let's move on from here. All right. So here we have our diagram. Now, it is important to know the name of, let us start with the cell itself. Let's start with the cell itself. Now, here for me, before I take you through these diagrams, looking at the diagram is one thing, but I would encourage you to do another thing, which is this. You can, if you have construction paper or cartridge paper, or you're as creative as my dear friend and student, Elaine.
That's you, sir.
Yes, man, very creative. Very, very creative. Very creative. Honestly, very creative. I think you should go into teaching. You'd make a good teacher with that creative skill of yours. Yes. Now, draw this for yourself and cartridge paper. Don't label it. Do not label it. But make sure that you know the names of the different structures on this parent cell as we look at it. So we have the nuclear membrane. Starting from the cell membrane, of course, the outer line is the cell membrane of the cell. They have the centrosomes, good, which has the centrioles, good. Now, so the centrosomes, and if you notice the word centro, coming from it would probably mean something like 100. I don't know why they use centro, but something 100, right? The centrosomes, which has in it the centrioles. So please make note of those things. And you can, when you draw the cell, you have some little shapes that represent it. Good. Because what you end up going to do for yourself, you're going to role play mitosis and role play meiosis. That's the whole point. Using the play method works, students. It helps you to understand, and when you understand, it further helps you to remember. So leave the memory part. Your brain will take care of that with the help of God, of course. Just do the path to understand. You see, when you use up your creative powers, I tell you, it calls you to think. And once you're thinking, you will learn and you will not forget. Remember, I told you that. Now, so so you have the nuclear membrane, and you have the chromosomes, you have the cytoplasm, and the nucleus right here, the nucleolus. which is different from the nucleus. All right. Then, okay. Now, you don't need to know the name of the stages according to CXC. So don't worry about trying to memorize the names. You must be able to describe it. All right. Now, so this is the interphase. So we're going into the interphase now. We're going now into the interphase. So during the interphase now, please note what happens. We have the spindle fibers being, spreading out from the what? Centrosomes. Good. And we have the sister chromatids and the what? The centromere. These are the little round circles. So if you notice what they did now, they join together. They start pairing. So pairing start to take place. Good. So the chromatids pair with each other. Blue with blue, green with green. Then now when you go into the prophase, they line up in the middle like they're at the equator. Right? And then of course you notice that the the centrosomes, they are like they form like what would probably in mathematics call the y-axis. You see that, like the y-axis. So or in geography like the Greenwich meridian. Good. And then the sister chromatids now lined up. They're lined up, and notice how they line up. Them pair up. Them pair up. Blue with green, green with blue, pair up. Good. At the equator, right at the middle, right there. Now, the same way that I am talking you through it, you are supposed to talk yourself through yours. Look in your mirror and teach yourself. If you don't have a little brother or a little sister to teach at home, teach back yourself. Nothing is wrong with that. Teach yourself. Because teaching yourself, you'll recognize where you're going wrong. Good? All right. So, so after lining up right there in the middle, right there, in the metaphase now, you realize what is to start happening now. You see that the cell membrane, like it starts to stretch, and then there's some division starts taking place right there. We also see the daughter chromosomes now, they separate. So you can literally see they start to divide in two. Use your own words. Them halving each other, they divided in two. I always tell my students, use your eyes. Your eyes. Describe what you see. Not what you imagine, but what you see. So you're seeing the division starting to take place right here. So first, they pair up, they line up, then they separate. So the chromatids separate. Good? The half. Then now when we go into the anaphase now, we see now that the another nucleus, two separate nucleus now are being formed. Good? Two separate nucleus are being formed, and each nucleus has its pairs of chromosomes. And then we can see now, going into our telophase, this big word right here now, that was mentioned by Shelley before, and we end up with now our daughter cells. So all you need to do in the exam is to be able to reproduce this diagram and explain in your own words what happens, and then simply um what you call it now, describe mitosis. And remember why it's important. Can you remind me why? Can you type in the chat for those on YouTube? And welcome. I saw 6 viewers, 6 persons viewing. And if you're viewing, could you just say good night in the YouTube chat and state which country you're from? All right. So we'd like to welcome you to CDP Laboratory Services. Okay. All right. Now type in the chat once again. Let's see if you're listening, if you're learned. What is the importance of mitosis? Go ahead and tell me what's the importance of mitosis, Elaine.
Mitosis is important
Mm-hmm.
for growth and repair
Mm-hmm.
of damaged tissues.
Growth and repair and
And it repair damaged tissues.
damaged tissues. Okay, very good. So for growth, repair, and damaged tissues. All right, good. Wonderful. All right. Beautiful, 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 beautiful. All right. So, all right. So, all right. So let us continue now. Let's continue now. All right. Now, so for mitosis, okay. So Fries says the importance of mitosis is for the production of identical daughter cells having the same number of diploid type of chromosomes as the parent cell. No, no, Freeze, that is not correct. It is important for the replacement of dead cells and for growth and repair. That is the answer, Freeze. But nice try. Nice try. All right? All right. Now, let's go over to meiosis now, the section for meiosis. So we're looking at meiosis on this side over here. Meiosis on this side. Let me use my Yes, let me use my spotlight. Yeah, on this side here, we're talking about meiosis. Now, if you notice, they're going to start now at the prophase, where they actually line up. So, right in the first circle here, we see crossing over taking place right here. Good. So they're crossing over, crossing over. Good. Now, so they're crossing over, and in the second circle, we see that the separation of the homologous chromosomes taking place. So they are separating. So there are homologous chromosomes, or they separate. Now, if you notice what is happening there, as they cross over, so the blue take a piece of the red, and the red take a piece of the blue. Now, this reminds me of genetic modification. Yes, genetic modification. This is what the scientist does. He learns from this part of me, me, um, meiosis. Good. All right. So they cross over, and then they have the separation of the homologous chromosomes taking place. Now, in the other phase, the anaphase part two, is have the separation of the sister chromatids. So after they cross over and they separate as homologous pair of chromosomes, then they start to separate. They separate now, separation of the sister chromatids, as you can see right here. Then no, so they are no longer identical. So variation start to take place right here because they are no longer identical. Good. So variation now start to take place right there. Now, going on further, you will see that we now have daughter cells, 4 daughter cells for the meiosis. Now, can somebody give me one importance of meiosis? One reason why meiosis is important. One reason why meiosis is important. One reason why meiosis is important? One reason why meiosis is important. Elaine, could you give me a reason why meiosis is important, please?
But different
Yeah, go ahead.
yes, sir. It's a different combination of genes.
But I want to know the reason why it is important. You're correct, Freeze. It is of course a variation. But what's all right, think about it now. It creates a variation in sex, gender. Good. And remember, it actually creates the gametes. Very good, Shelley. Meiosis is important um, to create gametes in both male and females. That's one of the reasons, right? Creation of gametes. Good. All right. So you must be able to draw these diagrams. Practice to draw them. You can use strings, you can use cartridge paper, strips of cartridge paper to do your thing. All right. And I expect my dear student Elaine to do a grand presentation for us for next class. How does that sound? Good news? Hello.
But
I am here taking you through it. So you better be prepared for that.
because I have another class tomorrow night and also on Tuesday.
No, we won't have a class tomorrow night. It's Monday
Oh, not
night.
it's
Monday.
Sunday night and Monday night. Right.
Okay. All right. Now, I don't know if you had to watch my video. Did you watch my video? Huh? Go ahead.
And the time that you start tomorrow night, because I have a class from 6 to 8.
6 to 8. Okay.
Yeah.
Well, I'll let you know the time for tomorrow night. I wasn't thinking of having it tomorrow night, but we'll see how it goes. We'll see how it goes. All right. Okay. Ruben says what? There's a wait. When is the next class? I'll let you know. I'll let you know at the end of the class freeze. And then Ruben says, thought it was this class. What you mean, Ruben? What you mean you say thought it was this class? What you meant, Ruben? What you meant? Oh, you mean the presentation, Ruben? Oh, hey, Elaine, Ruben was looking forward for that skeletal presentation. All right. I'm going to ask you guys to listen to this video. I created a video. So I'm going to ask you to listen to the video, and I'll stop it at intervals and we discuss the video. All right. I can give you, I'm not sure if you have access to this CDP Labs video, but if you do have access to it, you can rewatch it afterwards. But we're just going to watch it together and tell me if you can hear it on YouTube. And Elaine, let me know if you can hear it as well. All right, let's go. Oh, Ruben, I guess she'll try to prepare for next class. She will try to prepare for next class, Ruben. All right. Okay,
So
let's
I
go.
do fix I fix it, but
You fix it
explain it.
to
Yes,
explain it,
sir.
but you need to explain it. You need to explain it.
This is
No, if you try, no, if you try, all right, we'll give you a chance at the end of the class to try. How about that? Yeah, we'll give you a
right.
chance to try. Of course, trust me. And I'm sure Ruben will be happy to know that you will try tonight. Right, Ruben? All right. So let's listen to the video together.
Survival house. They will take the youths and bring them back into the schoolhouse. Education was saying, go get your education, me a beg you to revise where you learn from class, me a tell you no. Cause it's not hard, it's a task, just give yourself a chance and yes, you say that you grasp when them tell you no. Go get your education, me a beg you to revise where you learn from class, me a tell you no. Cause it's not hard, it's a task, just give yourself a chance and yes, you say that you grasp when them tell you no. Load the machine a better you
Welcome to another science and audio visual tutor. brought to you by yours truly, Ronique Bernard. Human and social biology, hereditary and variation is our topic for today. Preview. Gametes carry genes from parents to offspring. Genes are found along thread like structures called chromosomes in the nuclei. Each species always has the same number of chromosomes in the nuclei. All humans have 46 chromosomes in the body cells, which is a diploid number. Half this number of chromosomes is found in the gametes and is called the haploid number. Now, of course, my question to you then is how many chromosomes are found in the gametes? Okay, so each human gamete contains 23 chromosomes. So the answer to the question should be 23. Thus, when the gametes fuse during fertilization, each nucleus contributes 23 chromosomes to restore the 46 chromosomes in the zygote. The similar chromosomes are said to be homologous. Heredity. Now, note this picture. You have three different individuals. You have two female and one male. Now, if you notice that this female is much taller than this one. Now, in fact, these two females are sisters, and they are the Venus sisters. Sorry, the Williams sisters rather. So you have Venus in red and Serena in blue. And of course, Richard Williams, their father, is in white. Now, if you look closely, you will notice that Venus is taller than Serena. My question to you then is simply this: where or who did Venus get her height from, and who did Serena get her height from? Well, by the looks of things, it would appear that Venus took her height from her what? Father, and Serena possibly took her height from her mother. Now, we're going to, throughout this lesson, carry out an investigation to find out how is this possible. Now, the height that we're referring to is called the phenotype. Body structures which can be seen or which are present is called a phenotype. For example, height, hair color, and blood group. All right, so make note of that definition, all right, of the phenotype. So, just to remind you again, so when you look at yourself, I want, I, I gave an example of height, hair color, blood group. Could you, Elaine, and those in YouTube, give me another example of phenotype? We have height, we have hair color, we have blood group. Give me another example of a phenotype. Anyone? Elaine? Elaine?
Yes, yes, sir.
Could you give me another example of a phenotype, please?
Coming, sir.
Hmm. Freeze, we mentioned ear color already, Freeze. We mentioned ear color already. So you have to give me something that we did not mention. We mentioned height, we mentioned ear color, we mentioned blood group. So give me another example different from what was mentioned for phenotype. Note it is the body structures which can be seen or which are present, which can be seen. Just look at your body. Okay, you're forgiven. You're forgiven, Freeze. All right. Shelly says eye color. Good job, Shelly. Eye color is, of course, a phenotype. Come. Anything else? So we'll get eye color. Any other? Any other so we can continue playing the video? You don't have any, Elaine? Elaine?
No, no, sir. I was going to say I.
Okay. All right. Crystal Mattis says sound of your voice. All right. We could work with that. We could work with that. Of course. Why not? We could work with that. Sound of your voice. What about the length of your hair? Elaine, you could remember the length of your hair? Yes, length of your hair. All right, sound of your voice. Good night, Crystal. Welcome to CDP Lazarus Services. Could you tell me where you're from, please? All right. Face features. Okay, that's correct. All right, so let's continue. So you note then that the height that we were discussing before is referred to as the what? Phenotype. In other words, the character that is expressed, the character that can be seen. Now, the phenotype is controlled by what we call the genotype. What is the genotype? Now, the genotype is made from genes in the parents, or otherwise, the genotype is made from genes in the organism. So, therefore, the height or the phenotype is controlled by the genotype. And where do we find genotype? Or which word does the word genotype comes from? Yes, it comes from the word what? Genes. Note, the offspring inherited its phenotype from the parent. So we are saying that Venus Williams inherited her height from her father. Therefore, inheritance is the passing of genetic information from one generation to the next. So we are saying then that her father was in fact a generation before Venus, and then now the genetic information in from Richard Williams was passed on to Venus Williams, that is. Good. All right. Can you identify this structure? Ah, it's the what? Cell. And this is the nucleus. Can you identify this structure in green? Okay, it's called the chromosomes. Now let's see if you remember how many chromosomes are in a normal body cell. All right, answer that question. How many chromosomes are in a normal body cell?
46, sir.
46. Okay. Okay, welcome, Crystal. Welcome, CDP Lazarus Services. All right, so it's 46. Very good.
Okay, 46. My next
In all
question to
bodies.
you. Then how many
Okay.
chromosome is in a gamete? Yeah, half.
Yes, go ahead. How many chromosomes is in a gamete?
23. Sir, half.
23. Half. Yes, 23. All right. Crystal, Freeze, and you're all correct. And Jennifer, you're all correct about that response. All right, let's continue.
The number, which is 23. Now, which of the two words are used to identify 46 chromosomes? Diploid or haploid?
Which one?
Deployed, sir. So 46 deployed and uployed 23.
Okay, so 46 is the diploid and 23 is the haploid. All right, very good.
Good. Diploid. All right. Now, the chromosomes consist of the genes which makes up the genotype in the what? Parent. So we are saying then that the chromosomes, they consist, or the word consist means what? To make up. They are made up of the genes which makes up the what? Genotype in the parent. So in other words now, that the genotype which controls Venus height or determines the height of Venus is made up from what? Genes. Good. And chromosomes are thread-like structures located in the nucleus of a cell. Now here we have once again the chromosome, and you can see that it consists of what? Genes. Very good. Now, what is a gene? A gene is the part of a DNA molecule on a chromosome that determines one character. So let's read again. A gene is the part of a DNA molecule on a chromosome that determines one character. So you can see the gene on the chromosome, and the function of the gene is to determine one's character. For instance, if you note, as we were saying before, that genus height, her height was determined by a gene, and that gene controls her height. All right. Can anybody identify this picture? Yes, it's a what? A sperm.
All right, question before going any further. Let's just say if you're listening and you're paying attention. Where is the gene located and what is its function? Elaine, where is the gene located and what is its function?
The DNA molecules is
Where? You are describing it, but but where is it? The gene is on the on the chromosome, and its function is to determine the character. As I said before, the genotype determines the phenotype, right? Always remember that. Good. All right, Crystal. Yes, we are looking at the sperm cell now. All right, let's go.
Which is a sex cell. Note, sex cells are called gametes. So you have the sperm, which is a sex cell, and also the what? Ova. And then each human sex cell carries 23 pairs of what? Chromosomes. Once again, it is referred to as the haploid number. The sex cells are produced by meiosis, a form of cell division. Now we're going to go straight into what meiosis is about and what really happens when meiosis is taking place. But before we go there, I want to share this with you. It states that gametes are made by ordinary body cells dividing. So, like you have your skin is ordinary body cells. Everywhere in your body is made up of what? Cells. And those are ordinary body cells. Good. Now, for example, human sperm are made when cells in a testis divide. So the body cells that contributes to the production of sperms or sex cells would be the what? The testis. Good. The cells that makes up the what? Testis. Now, because gametes need to have only half as many chromosomes as their parent cell, division by mitosis will not do. So when gametes are being made, cells divide in a different way called meiosis. Right? Very good. Now, this oval shape,
I want you to pay close attention to this demonstration. All right? Pay close attention to this demonstration.
will represent our parent cell, which contains 4 chromosomes. Okay? Now, note that in fact it should have a total of what? 46 chromosomes. So the parent cell normally has what? 46 chromosomes. Now, let us take, for example, that this oval shape is representing the cells in a what? Testis. Good? All right. Now, if you note that you have two yellow bars right here. Now, one bar is called a chromatid. So 2 bars is referred to as the what? Chromatids. So chromosomes are made from what? A pair of chromatids. Or in other words, a pair of chromatids makes a what? Chromosome. Now I'm going to ask you now to closely observe what is happening on your television screen.
In this case, you heard me say television screen because before we came live on internet, we used to produce the lessons on DVDs and give our students who comes to an in-person class or what you probably call face-to-face class. So these videos were made long ago, and when our students utilize these videos and do the worksheets and come to class, to God be the glory, they have never failed human and social biology. And one of our top students, Chevel, she actually got a grade 1. So uh, once you follow instructions, I'm quite sure that you will produce a grade 1 and you'll tell us when that time should come. All right, let's continue.
Okay. You notice that the homologous chromosomes pair together and they will cross over. And crossover will what? Take place. So they were separate before and then they what? Pair together. So the homologous chromosomes they pair together. Now what do we mean by homologous chromosomes? Now if you notice now that these two are alike and these two are also alike. So homologous means chromosomes that are similar. If you notice they cross over and you see an exchange taking place right there where a blue piece of this chromatid attaches itself to the yellow piece of this chromatid and a yellow piece of this chromatid attaches itself to this blue piece of what chromatid. So when they cross over, what you see happening there is an exchange of genes taking place right there. And it is said that this crossing over contributes to what we call variation. In other words, it let the new individual looks different, right? So crossing over in the meiosis process contributes to what we call variation. Or variation is caused by the crossing over of genes. Now, notice now what is going to happen in this part of the lesson. If you notice now that the homologous chromosomes begin to what? Separate. One from each pair goes into each daughter cells. So these two circles are representing what? A pair of or different daughter cells. And you notice that the chromatid they separate and they go in what? Separate daughter cells. Very good. Very good. So this is the first stage of meiosis. So what happens in the first stage of meiosis is simply that the homologous chromosomes they pair together and then they separate one from each pair going into each daughter cells. Now we're going.
Is the lesson clear so far to you, Elaine?
Yes, sir.
Just clear. Okay. Those on YouTube, could you let me know if the lesson is clear to you so far? If you're following, if you're understanding, just let me know if it's clear to you. All right.
Into the second stage of meiosis. Now note that these are four more what? Daughter cells. Now, do you know why they're called daughter cells? Yes, simply because the parent cell itself is basically what? Dividing into different what? Into smaller cells. So the parent cell divided first into two daughter cells, and then it continues to divide into what? Four daughter cells. So this is why we call it cell division. So the cells of the testis then, they are basically what? Dividing twice, once here and then in a second stage right here. Now notice now what happens in the second stage. Very good. Now, if you were noticing that each daughter cell looks different from the parent cell, isn't that so? Good. So this is one reason why you say that why it is said that meiosis contributes to what? Variation. Good. Because each of these daughter cells are carrying um, parts of the chromosomes that were in fact in the what? Parent cell. Good. Now note that each of these daughter cells are in fact gametes and they are in fact sperms in relation to the male. So each chromosome separates into two chromatids. One chromatid of each kind goes into each daughter cell, as you can see. Very good. I'm sure some of you may be able to identify these two ladies. All right. However, they are going to help us to look at inheritance with dominance. Are these two sisters? State one difference between the two girls. And if they are sisters, why would they look different?
Yeah, these are pictures of two of my past students from where I work. These pictures were took long ago, and they are not twins. They are not the same age. Surely, the darker one is actually older, and the clearer one is actually the younger sister. All right. So, but they are from the same parents. Good. So let's continue with our lesson here.
And my next question, what causes the difference between these two sisters? Now, yes, they are sisters. And one difference that you can identify is that if you look at their skin color, it is what? Different. Now, this one is a browner than this one. In fact, this one is of a darker color and she's brown. So that is one difference. Now, others may be looking at their body size, that this girl may be stouter than this sister. No, if you're wondering if they are the same age, no, they are not. The one in white is the older sister, and of course, the one in black is the younger sister. No, question. If they are sisters, why would they look different? We are yet to answer that question. But let me give you a little history about these two. Okay, so both these girls are sisters and they share the same mother and father. The mother is dark while the father is brown. They are not twins. The brown girl is younger than the dark one. Question: what is the genotype of both mother and father?
All right. So, okay, I see what you said, Shelley, on variation in genetics. That's where we're going to right now, definitely. Um, this is the basis now of majority of the CXC questions that comes in section C of the syllabus. The question, what is the genotype of both the mother and father? So I want you to pay close attention because sometimes this is the part that most persons find difficult to do. All right. If you want access to this video, you could go to our website, as you can see in the banner running across our website address, and you can click on the join us on join us on WhatsApp, and I will send you the video link via WhatsApp if you do not see this on our channel.
Write that question down. Terms to be used and their definitions. Dominant, it says, an allele controlling the characteristics shown in the what? Phenotype. So that's what we mean by dominant. So it is saying that there's an allele controlling the characteristics shown in the what? Phenotype.
So the allele then is like your president of the United States or your prime minister in your respective country, or let's say in Jamaica or in Guyana or in St. Vincent and the Grenadines or in St. Kitts and the Nevis. So remember, it says the allele that controls the characteristics shown in the phenotype. So, as I said to you before, remember, try to remember the vocabulary used when you're practicing with your when you're teaching back yourself with your toys, and I call them toys, your models, just like what I showed you. What we're going to break a bit in the video though to give Elaine a chance to start her presentation briefly. Just she may not do the full thing, but just briefly, right? Right, Elaine, are you there? Elaine,
Still, yes, I'm laughing.
yes, remember, we can't make Ruben feel bad, and we have to help. We have to bless up Ruben tonight. Ruben is looking forward. Ruben came directly to see this presentation. He said, "I thought it was tonight." Okay, so Ruben is looking forward for it. We can't make our visitor feel unhappy, right? All right. So we're gonna break in the video a bit. Tell me if you are enjoying the lesson. If you are enjoying the lesson, say I am enjoying the lesson. Um, if you're enjoying the lesson, just let me know if you are enjoying the lesson, of course. And we'll take a break in when I say the lesson, I mean the video that you're watching. And we'll take a break and allow Elaine to do her presentation, and then we'll continue with the video. But let me take you through the vocabulary part. At the end of the vocabulary, on this section, this slide, then we'll ask Elaine to demonstrate what is expected to you, what you are expected to do. All right?
In other words, let us say that you had two brothers, and one seems to be stronger than the other. So you find that the stronger one would be the one in control. Good. So it's a similar scenario or a similar situation with the allele. All right. Now, allic pair. So the word allele, allic, is coming from the word allele. Now, a pair of genes controlling alternative characteristics. So therefore, the allele, they are a what? A pair of genes. Now, how many genes then would make up this pair of genes? Not one, but two. So two genes make up a pair of what? Genes controlling what we call alternative characteristics.
Okay,
What
good
does the
night,
word
Freeze, and all the
alternative
best.
means? Now, the word alternative simply means, well, in other words, one after the other. Or it could mean this one before that one, or it could mean opposites, right? Good. But a little later, we'll get a better idea what the word alternative means in terms of genetics. Okay, so a pair of genes controlling alternative characteristics which occur at the same place on homologous chromosomes. So locus here is another word for place, recessive. The allele which is not expressed when inherited in the heterozygous condition. So therefore now the pair of genes are both dominant and recessive alleles, right? So allele can be dominant and or recessive. So an allic pair of genes then are made up of a dominant gene and a recessive gene. Let me say this again. An allic pair is made up of a dominant gene and a recessive gene. So the pair of genes that they are referring to is the dominant gene and the recessive gene. Very good. Now here is an example. Now here we have,
All right, so we're gonna pause the video here. All right, and I thanks to Jennifer and everyone who has been watching so far that said that you're enjoying the lesson so far. Remember to get the full video, both part one and part two of this video that you're watching. You can go to our website and you can click on the join us on WhatsApp, and then I'll send you the link for the video so you'll be able to watch it in its entirety. All right, but I will allow you though to watch this the full part of this after the brief presentation from Elaine. Are you ready, Elaine?
So give me a minute, please.
Okay, so we're gonna give Elaine a minute. So as we get ready for Elaine's presentation, um, she's going to demonstrate to you what is expected of you when you're on your own preparing for the exam. And this method that she's going to be showing, I must tell you that it is an important thing to do, right? Because, as we, Elaine, when you're ready, let me know, please. In preparation for the exam, CXC marks the exam on two skills for your the two skills rather, right? And the two skills are KC, which means knowledge and comprehension, and of course, the second is your ability to use knowledge, UK, use of knowledge. Now, if you are not using the knowledge, then how are you going to be able to express it in the exam? So, what Elaine is about to demonstrate to the class is what you're expected to do. You understand? This is the most important part of our lesson, right? And one of these days I will show you. You can visit the channel again, and we'll show you examples of our students other exams of our students doing presentations, and I'll show you one of those lessons that one of our top students who got grade one in human and social biology just come into the school for 4 months. Just 4 months she came to the school and she did well and she got a grade one. And last year, one of our other top students, she got grade two just after coming to the school for 2 weeks, using the same method that Elaine is about to present to you. So I just want you to pay close attention as we um, get Elaine ready to do her presentation. All right. I just want to, as we wait for Elaine, just want to welcome those persons who have been viewing. Um, Welcome, Crystal. So we are ready now to get to Elaine. So just give me a second there.
Sir,
Yeah, man,
um,
we're ready
are
for
you
you.
speaking? Oh,
Yeah, we're
all
ready
right.
for you, Elaine. We're ready for you. Just going to pin you. All right, turn your device long way, Elaine, so you can turn it long way. No, the device, turn it long way. No, long way. Yeah. All right, your camera is off, but turn it long. Turn it long way. Ah, perfect. Excellent. All right, so here is Elaine doing her presentation. Everybody seen her Elaine skeleton? All right, go ahead. Take the show, Elaine. It's yours. It's all yours.
Okay, okay, sir. I'm the topic, but I will try something.
Yeah, man, go ahead.
Okay, here we have a skeleton system consists of 206 bones. So you see it clearly, right?
Yeah, man, I'm seeing it clearly. Yeah, go ahead. I'm not hearing it clearly as well, so go ahead.
We know that the cerebrum, the cranium, so the cranium is the head. The part the cranium is the head,
Mm-hmm.
and it's put the brain. What I'm doing so far, fine.
Yeah, good. Mm-hmm.
And the skull consists of cranium, the upper jaw, also the lower jaw. May not show there, but just imagine it is there.
Yes, yes.
Also, this part here is the rib cage. Yeah. And somewhere here. I mean not always the explanation part. I know what I'm saying, but I don't know what to explain.
No, man,
Maybe that
explain in your own words. That's fine. I mean, the guys are loving it. You see, Shelly says amazing. Well, in Guyanese expression, wash hands, wash hands. She's happy. And Ruben says, nice, nice. Ruben is happy. So you're doing well. So continue. Continue. You're doing well, man. Continue. You're starting
we
off well by identifying the different structures, which is very good. So continue doing that, and you'll get comfortable. Mhm.
we have the ribs here as you see.
Mhm.
Down this part, we have the vertebral column, and we know that the vertebral column consists of two parts. The axial and the appendicular. Correct, sir?
Yeah. Well, the vertebral column is a part of the axial, right? Touch the vertebral column first. Touch the vertebral column first. Touch which part of your skeleton represents the vertebral column. Just touch it. Show me the vertebral column. Very good. That's the vertebral column there. And what does the vertebral column protects?
It protects it is fine.
The spinal cord. Very good. So what you could do first is just to identify them based on what you're doing. Do that first.
Okay.
Mhm.
Okay.
Mhm.
Here we have the shoulder here,
Mhm.
and it's the pectoral girdle. We
Mhm.
have the the humerus right here,
Yeah.
and also the phalanges. I call it my
In the
fingers.
hands. Okay. Could you show us what show the joint at the top and tell us the name of the joint at the top? Right to the
This
shoulder
is
there.
the shoulder.
Yeah, what's the name of the joint right there?
This is the shoulder blade. This
Well,
sternum.
yeah, go ahead.
This sternum.
Hmm. What's the name of the joint at the top there?
We have here now the ulna right here,
Mm-hmm.
and we have phalanges right here. The
Mm-hmm.
top is between the joints right here. The top part.
Yeah.
Correct, sir?
Yeah, man, continue.
Okay. Yeah, also we go, and I think I was told that the leg part here is the biggest bone for that, sir?
The long bone, yeah.
The longest bone. The
Mm-hmm.
thigh is the longest bone.
Mm-hmm. You remember the name of it?
Femur, we
The
call that
femur.
femur.
Femur. Very good. Very good. Femur, yes.
And we all know that this joint here,
Mm-hmm.
the patella,
Mm-hmm. That's the bone. Mm-hmm.
and right here, we call the tibia. And we know so this part here is also the phalanges.
Mm-hmm.
And the tarsal is somewhere here.
Go down some more so we can see. Mm-hmm.
Right, somewhere right here. That's the tarsal. Yes, sir.
Okay. Okay. Well, not bad. Not bad. Being that I mean, I just want to say to everybody, she's not yet fully prepared, but she didn't want to disappoint, especially Ruben, right? And Ruben says nice, 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 good. And
To
yeah, go
write
ahead.
it out. I didn't get anything. anything to prepare the papers to just to present and just
I
get the time.
know, I know, I know. And that's why we're taking our time with you. All right, very good. Very good. So when she's more prepared now, you'll start to see the dynamics. But she gave us a glimpse of the dynamics when she started off by speaking about the cranium, and just by identifying the cranium, she automatically went into stating the function of the cranium to tell us that it protects the brain. And this is the power of making your models, students. When you have your models, like, and I'm not the only one that agrees that you're creative. Shelly says yes, man, she's quite creative. Yes, right. um so you guys, you haven't seen anything else. You haven't seen nothing yet from Elaine. What have they seen the cells? Right? So, but the power and the dynamics of it, Elaine, is that you're once you're able to identify them, once you practice to identify the structures, automatically things will flow right in to the functions of each of these structures, and be able to identify where the different joints are and what the joints are, etc. So every system that we study in the syllabus, make yourself a model. You understand? Make yourself a model. And this is where we're talking about reteaching. And what Elaine needs to do, I mean, for the difficult areas that you may probably find yourself having, is to make videos of your own, teaching back yourself. Once you're able to, utterance does a lot. Well, Ruben says he'll be waiting indeed for the more prepared. Jennifer says, nice presentation. Now, can you imagine if this one is nice? Can you imagine when you are prepared, Elite? Much better, right? Good. So, uh,
Yes, sir.
right, good. So, I just want persons to know that there's a powerful method in doing things like these, and I implore you, Elaine, to start making those little videos. I mean, yes, it might think that the times are short, but teaching back yourself, um if just making the short videos will help you, and it can be done. It can be done. It can be done. And good job so far. And I want you to continue to do these things. Don't stop. But making it is one, but the other is what? Using it.
Yeah.
Clear, ma'am?
Yes, sir.
All right. Thank you very much. So we're gonna go. You can switch your video now. We're gonna go back to our video now that we were watching before. All right. So persons. So Ruben, Elaine did not disappoint. Um, and we were looking forward for this presentation. So we see that you guys enjoyed it so far, and I'm saying, do not study the syllabus. I mean, do not miss the next night. And if it's the first time you're coming on, ensure to subscribe, because the next night will be more presentations. All right. Now I'm gonna let us finish the video for this phase. And remember, you can go to our website and you click on our home page. You're going to click on join us on WhatsApp, and then you'll be able to access us on the WhatsApp, and just remind me what your request is, and the request is to get the genetics video, and we'll send a link directly to you so you can have the video to watch over in your own time. It's the entire video is based on section C of the syllabus. So when you watch the chapter 1 and chapter 2 of the videos, you'd have covered section C of the syllabus in one go. All right? One go, just like that. All right, let's continue.
A homologous chromosome. And you can see that the allele for brown skin is in the same position as the allele for dark skin, but they are on two separate what? Chromatids. Very good. All right. So in some case, the allele for brown skin, in terms of say the younger sister this time, this allele was in fact what? Dominant, and the one for dark skin was in fact what? Recessive. So in other words, the recessive gene, which is the one that controls the dark skin, would not be expressed, would not be seen. The effect of that gene will not be seen. But the effect of the gene that controls the brown skin would be seen or be expressed. So in other words, then we are saying that the gene that determines or the phenotype brown skin was in fact dominant um, for the younger sister. But the question still is there. Why is it then that for the older sister, that is it that the father is it that the father in the sperm that fused with the mother's ova, the chromosomes there did not have the allele brown skin, but they were both dark skin? That's a question for you to think about, right? Good. So in this picture, then, we are seeing that the allele for brown skin is dominant and the allele for dark skin was recessive in the case of the younger sister. Another term, heterozygous. Now, both alleles are present at a locus, one on each of the homologous what? Chromosomes. What do I mean by that? Now, if you note, heterozygous suggests that you have what? The different what? Alleles. So they are both present and one on each of the chromosome. But why we say it is heterozygous is because you have two different alleles, one for brown skin and one for dark skin. Then we have homozygous. The locus has the same allele on each of the homologous chromosomes. What do I mean by that? If you notice, it says the locus have the same allele. So the locus for skin color gene is brown skin right here. So they're in the same position, and guess what? Both chromatids have the same allele. Brown skin, brown skin. So when it is homozygous, it means that the the chromosome will have the same alleles on each homologous chromosome. So heterozygous is when you have what? Different alleles, and homozygous is when you have the what? Same alleles in the same location. Good? Very good. Okay. Now we're going to use what they call a genetic diagram. Okay? Cross diagram. Now the parent's genotype for the father, it could be BB, well, capital B. And why we have 2B is simply because you have this would be, for instance, the father body cells would have BB, and then that will be crossed with the mother's ova, which could be common B.
All right. Now, so here we're going to be explaining now. This is a part that some persons have a problem with. So I just want you now to pay close attention to what is taking place right here. So if you notice now, it, this is called the Punet square method. All right, this is the Punet square method. Now, well, not this one, not this one. This is a cross one. The other one coming up is a Punnett square. But notice what you when you're answering the genetic questions, you have to put the genotypes. So you put the phenotype at the top, and you put the genotypes right there with the letters. Good. So we have big B, two big B, which is two dominant genes, right? Homologous pair of genes, and then for the mother we have two recessive genes, which is two common genes, another pair of homologous alleles, right? So let's continue.
Now, big B would be dominant and common B would be recessive. Now, they are going to separate, as you know, in meiosis. So you have a sperm which has big B for the father here, and a sperm which also have big B. So we are saying, and it doesn't matter which of the sperm fuses with the mother's egg. Good. So here, the mother has her eggs, small b. So both the mother's egg is carrying the gene for dark skin, and both the father's sperm is carrying the gene for brown skin. Now we're going to have some segregation taking place here. Now the offspring here will have big B from his father and little b from his mother. Good. So this offspring, as I said, big B from her father, sorry, and little b from her mother. So therefore, the offspring genotype could be what? Big B, small b. And this would make her what? Brown. Now, why this would make the daughter brown? Simply because big B would be the dominant gene and little b would be the recessive gene. So, of course, if big B is the dominant gene, it means that the character which is controlled by the dominant gene would be expressed in the what? Phenotype. So, this is why this young lady is brown. And then, in this case right here, father, hold on there, big B again, and from mother, small b. Very good. So, the in both cases, you realize that if the father has, if the father, if any of the two sperms mate with the mother, you will still have a, a chance of the child still being what? Brown. Good. And let's look again. Another big B from the father
Understanding so far, Elaine?
and a small
Yes.
b from the mother.
Okay.
And a big B from the father again, and a small b from the mother. Now, what is this saying to you? Now, we're looking at the proportion. In all cases, we have a 2 to 2 what? Ratio. Now, that can be written like this. 2 to 2 ratio. So this is simply saying that there's an equal chance, or in all cases then, if the father goes and have sex with the mother, then the child will come out brown if the father has both if the sperm, if both sperms or all the sperms rather has BB, big B, good. So in all cases, then the child would be what? Brown. But evidently, the father is not two big B's because the first child was dark and not brown. Good. So therefore, the father cannot be two big B. All right.
All right. So notice how and yes, Shelley, you are correct on that. And yes, Shelley, you are very much correct on that. So Shelley says, just to highlight what Shelley says for those, 1 second there. Yeah, just to highlight what Shelley says. She says the father is homozygous dominant and the mom was homozygous recessive. The children is bound to be heterozygous. Excellent way of putting it. Right? Well done. Now, this is the investigative part of genetics. So we started off by using because when you need to find out the genotype for both parents, you have to do something like this, or do this rather, as a part of the investigation, so that you can determine the genotype of both parents. All right. So this is what you use to determine such. Now, when you reach the racial part of it, we're not saying that the father they're having four kids. We're not saying that. But we're saying the chance of that a child, let's say they were having the first child, let's say the older sister, the chance of having the older sister, if the father was dominant, big B, dominant homozygous, and the mother was dominant recessive, then the older child would come out brown. That's what we're saying. But in another scenario that you're going to see coming up next is that the there's going to be another ratio now that tells us the chance. So we're talking about the chance now. We're not talking about the quantity of offspring now, how much offspring is going. When I say that four offspring going to come forward, but the chance of this one offspring, what will their color type be, their skin type be, right? That is what this is telling you. So let's continue.
But the phenotype for the offsprings would be brown skin in this case. That it all be what? Brown skin. So note, if the father is a homozygous big B and the mother is a homozygous recessive, which is small b, then of course the father's gene, if dominant, the child will take the skin color of the what? Father. Good? All right, let's look at different cases now because we need to investigate still. So when you're doing the CXC questions and you're asked to show a genetic diagram to explain different cases, then you need to set up something looking like this. All right? And you don't just write one and leave it like that. You try different combinations. All right? Let us see now if the father if the father was big B and small b, what would happen? And the mother was also big B and small b. So that is possible too. It is possible that both father and mother has the same genotype. But is it true? Is it true? The mother is dark, isn't she? So she could not have a big B. Good. So therefore, it must be two what? Small b's. Okay. Let's cross them now. So we have from the father, one sperm will have a big B, and the other sperm will have a small b, and the mother's egg is two little b's. Now, if you notice now, these are the gametes produced. So this sperm can fuse with this egg. See, they are fusing. So that sperm fused with mommy's egg. The child is still brown. Then this egg will fuse with this sperm, rather. The sperm will fuse with mommy's egg, and the child can still be brown in this case. But what if the sperm with little b fuse with the egg with little b? Then the child in this case can be what? Dark. So you see that a father who's brown, the child doesn't necessarily will come out brown like the father. It depends on the sperms that fuses with the mother's what? Egg, right? Because remember, because of meiosis, as you could see when you saw on the daughter cells, one of each kind went into the daughter cells. So you find that maybe, I remember you had four daughter cells. In this case, we show you what? Two daughter cells, right? For the father and two for the mother. So you realize that the daughter cell that carries the brown skin gene could have fused with the egg of the mother and the child becomes brown. Or the sperm that carries the gene, the recessive gene for brown skin could fuse with the mother. And in this case, the child will come out what? Dark. So in the case of the first child, which is the girl in white, obviously the sperm that carries um the little bee fused with the mother's egg and allowing her now to be what? Dark. Good? So therefore, it depending on which of the gametes, which of the sperms then would in fact fuse with the egg. And the truth is, the different sperms will carry different genes. Good? And you're seeing that clearly. And of course, once again, the same thing right here. So you see then, there's also once again a 2 to 2 what? Ratio, where there's a 50% chance of the child becoming brown and a 50% chance of the child becoming what? Dark. So it is possibly then that the father has a genotype of big B and small b, and the mother has a genotype of two small b's. So this big B and small b would refer to as heterozygous. And so a heterozygous father, when mate with a homozygous mother, it is a 50-50% chance that the child may look like the father or may look like the mother. So the father then obviously has a dominant um, allele for brown skin and also a recessive gene for brown skin. Good. So we are going to look at another scenario. Now, the following photograph displays the Williams family, Venus and Serena Williams and Rich.
All right, so we're gonna stop it right here. As I said before, if you would like to have access to this video, you can go to our um, website and you click on join on Join us on Facebook. Sorry, not Facebook, but on WhatsApp, and you could let me know, remind me of the video that I promised to send to you, and I'll send to it in a private chat. All right. And you have seen my number there on the screen as well. I hope that the lesson so far has been, as you know, at the end of each lesson, I normally ask the students to evaluate. So I just want you to, if if you feel that the class has been beneficial to you thus far, then I would just ask for you to click on the like, of course, the thumbs up button. Give us a thumbs up, and you could express um, your feedback also in words in the chat. So at the end of we come to the end of the lesson tonight. So we'll just ask that you express how you felt about the lesson in the chat tonight. How was today's lesson for you tonight in the chat? Elaine, how was your night for tonight?
So it was good, wonderful. I enjoyed, although it was, me alone, but it was wonderful.
It was
Yeah.
wonderful. Okay, maybe another night we can probably. I don't know if Ruben want to join us in Zoom, or Jennifer want to join us in Zoom next class. If they want to join us in Zoom, just let me know. If you want to join us in Zoom, just let me know, and then we'll add them to the group so you can have company. All right. And okay, so you said the class was good for you tonight. All right. Okay. But tell me something though. How you felt when you were doing the presentation a while ago? I forgot to ask you that. How you felt when you were doing the presentation a while ago?
Never, sir,
Nervous.
because I, maybe if it was like, my student that I go with every day, that will every day will be different. But
Hmm.
those are here on YouTube.
Yes.
Yeah,
Okay. 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 All right. Well, Jennifer and Ruben is requesting an invitation to join us on Zoom. All right. To join us on Zoom, Ruben and Jennifer, you can join. You can go to the website again, and you can click on join our Facebook group. So you can click on join us on our Facebook group, and you'll see the link there. Next time we post it, we'll post the link for the next class for YouTube in our Facebook group. So you can go to our Facebook group. Just go on the website www.cdplabseduservices.com, and you can click on join our Facebook group, and then you'll see the link there when it's posted for the next class. So you can join us live on our Zoom session. So I want to hear from you guys. How was tonight for you? Ruben, Jennifer, Shelly, and of course, the rest of you who have been watching. I see 12 likes, and I do appreciate those 12 likes. And thank you for being here with us. All right. So as we wait, so Elaine, just make sure now that you do what I tell you to do. All right, you have to practice. Make sure you have it for. Did you complete all the systems? Did you make the model for all the systems?
no, sir.
Huh?
I didn't have the time because I was focusing more on English
Oh,
and I didn't get much time to complete all.
okay. Well, you have tomorrow. You have Monday. The technical the 3 days to practice, but ensure that you guys study the diseases. Ensure to study the
Yeah,
diseases. I promise tomorrow that we will start back with once you collect this video, then I don't need to show the rest of it. All right. So once you request the link, then I'll send a link for you, and it definitely does not need for us to continue watching the other chapter. You can watch it on your own time. But we're gonna go back to our past paper question in our next lesson, continue with January 2021. But tonight was just to introduce you to the video and also look at the technique that you should use when you're preparing, a shorter method to use when you're preparing for your exams. So it's good night to you, Elaine. Thank you very much for joining me in class tonight, and I sincerely wish you all the best when the exam come. I'll be saying it every night until till Tuesday night, right? Tuesday, not Tuesday night, Tuesday evening. We won't be having any class Tuesday night. Okay. Shelley says, could we look at the January 2021 past paper? Well, Shelley, you're kind of late now. We started on Thursday night. So we'll be continuing tomorrow night and into Monday. All right, Shelley, you're kind of late on that one. Ruben says, yes, it was pretty good. I learned more indeed because we didn't do much of the practical part due to our setbacks in St. Vincent. Okay, I understand that, Ruben, and for sure, um, there's more that you learn from the video. Just remember to go to the website and get those things done. Okay, Shelly, you look at the Thursday one. All right, cool. All right. So I got Ruben's feedback. What about yours, Jennifer? And what about your Shelley? What was the class like for you? All right. And we know that Freeze had to go because wherever he is now, it's probably minutes 12 in his country. All right. So that's it. Elaine, thank you very much. You may go and get continue sleeping or continue studying. Which is it?
Sleep, sir. We don't
Sleep.
want to sleep.
All right, go and get some rest. That's why I keep calling you to make sure you're staying awake. All right, you can go. So you have yourself a good night, ma'am. All right, so good night again to you folks. I just want to take this opportunity to um, welcome welcome to CDP Labs Daily Services once again. For those persons who have been viewing us live on our YouTube channel, I want to say a special thank you for those who have liked tonight's class. I see 12 persons, and a special thank you for those who have subscribed to our channel. Let's keep the subscriptions going. Share it with your friends because you know it does well for the channel, and it helps us to continue doing what we're doing to put students first and to help you in on your way to having a successful exams. Jennifer says, it was great. I learned more indeed. Was having problem with this topic. Thank you so much for this lesson. Well, you're definitely welcome, Jennifer, and to God be the glory. As I said before, if you want the other chapter of the lesson and the completion of the lesson, then you go to the website and you click on join with join with us on WhatsApp, and just send a message in the WhatsApp group, and I'll just remember and I'll send a link to you separately for these two videos so you can have them to watch and so forth. All right. And just want to take the opportunity now to invite you to our virtual information session. All right. I just want to invite you to our virtual information session. Um, just want to, we'll be having for our virtual information session, we'll be having our um well, let me tell you who the presenters are. Just give me a second, please. And it is something not to miss. It is something not to miss. Trust me, not to miss at all. All right, just going to show you the flyer. All right, just going to show you our flyer, and we just want to invite your friends to tour. Yeah, so it's coming up. Flyers coming up now. Yeah, so we just want to take this opportunity to invite you to our CDP Labs Edu Services virtual information session, and our theme is sharing my experience to inspire you. That is our theme, sharing my experience to inspire you. And one of our international guest speaker, she's of course Mrs. Camila Palmer Jahai. She was one of our past students. Yes, she was one of our past students at CDP Labs Data Services. She came and did her subjects, and having done her subjects, she moved on to the Northern Caribbean University, where she did her bachelor's degree in marketing, and of course, she went on further and to do her master's in business administration. So she now has her master's degree, and she's now a junior accountant living in Canada. So she will be our main presenter. And of course, one of our other guest speaker, Mr. Kimani Bernard, he's going to share his inspiring story his experience to inspire you. No, he wasn't a past student, but he was one of our instructor. But he has a story to tell and to share with you. And of course, his journey started out with an associate degree. I will not give you much, but just to highlight who he is. He had an associate degree in business administration and management. He went on to Michael Teachers College to get his bachelor's degree in education, business education that is, and of course he went on getting his master's of science in accounting degree. So he now has his master's degree in accounting, master's of science degree, and he's a lecturer plus he's a chartered accountant. So I'm asking you to invite your friends. Go on to our Facebook page, and you can subscribe to the event, and it will be on the 22nd of August, 4 p.m. Jamaica time, and we'll be looking at our 6th associate degree program, and we're talking more about our City and Guilds program, and of course our CSEC program. So I invite you. This is your official or your unofficial invitation to our virtual information session, and our theme is sharing my experience to inspire you. So, once again, from CDP Labs, this is Mr. Bernard. Thank you very much for being here with us. Take care and have yourselves a good night. Good night. All right, ciao. Good night. Take care to you all.